This is 1.9 in your textbook. It's the absolute value equations and inequalities. I've got about a dozen problems here to run through. But to start with, I'm just going to go ahead and get some of the basics done here. Now, the absolute value of any number is the distance. So absolute value is a always positive number. We're always looking for an absolute value. It is neither positive or negative. It's technically without sign. If we are looking at the absolute value of some variable x, and they tell us it's a value c, then it could be that that x, that original x, was c, was whatever that value is, or it could be that x was the opposite of that value, or negative c. This is the way we deal with it with equations. If they're inequalities, what you need to know is that the absolute value of x, if it is greater than c, then it is true that x itself could be bigger than c, or the opposite again could be true, and x is less than a negative c. So x could be bigger than c, or it could be that x is smaller than the opposite of that c. Think of it in terms of symmetry, and where the 0 is on the number line, greater, and then the opposite is true on the negative side. If we have the absolute value of x, which is less than c, then it has to be true, because it's less than, it is closer to, that x value could indeed be less than c, but it must also be, so this is an and, that x value could be greater than the negative c. So the less than here for an absolute value basically gives us limits. The greater gives us wings. So if we're looking at a number line, the greater, there's c, there's a negative c. The greater gives us an open circle and wings in either direction. Greater gives us wings. And the less than bounds us. So it makes it stick between. These are general rules. They're not 100%. Like I've said before, it's just like 85 to 90%. Right? Okay. These are the three that you need to kind of keep straight. Those will help us as we do the rest of the problems here. All right. Solve that first one. The absolute value of x minus 3 is equal to a 2. If we use our 3 tips here up at the top, since this is equal to the x minus 3, what's underneath or inside the absolute value, that x minus 3 could be exactly 2, or it could also be true that that x minus 3 is the same as a negative 2. This gives us 2 mini problems to solve, each of them very similar. I'm going to add 3 to both sides, so my x could be 5. Or, since I have to consider the opposite value, I can add 3 to the negative 2, and it could be that x is equal to 1. So my x values here are a 1 or a 5. There are 2 possible solutions. I can check them. 1 minus 3 is a negative 2. Absolute value of a negative 2 is a positive 2. And if I put a 5 in, 5 minus 3 is 2, and the absolute value of that is 2. If you have a slightly longer problem, as you see here in number 2, all I'm going to do is treat this as a single entity, and I'm going to try and isolate it as I did over here. I'm going to subtract 6 from both sides. 3 times the absolute value of x plus 5 is going to be equal to 9. Then I'm going to divide both sides by 3. So we have the absolute value of x plus 5 is equal to 3. Now that I have isolated that absolute value, it could be that x plus 5 itself is equal to 3, or it could be that the x plus 5 is the opposite of that and equal to a negative 3. Again, giving myself 2 little mini solutions Subtracting 5 from the first one, I get my x could be a -2. Subtracting 5 from the second one, I get my x value could be a -8. So I get x is equal to a -8 or a -2. If you're unsure, you can put the -8 into the problem. -8 plus 5 is a -3. Absolute value of a -3 is 3. Times 3 is 9. Plus 6 is 15. If I put in a -2, I have -2 plus 5, which is 3. Times 3 is 9. Plus 6 is 15. So I do know that this one is also correct. And I got a correct answer here, and I got a correct answer here. Put them in the box. All right. Okay, let's try a few with inequalities. All right, number 3. We're looking to solve these absolute value inequalities. Answer in all 3 ways because they're inequalities. Can we answer it with set notation? Can we draw the solution on a number line? And can we write it out in interval notation? So I'm going to do all 3 for all of these. You won't always be asked for all 3, but I'm going to do my best to demonstrate. All right? So let's take a look at that first one. The absolute value of 2x is greater than 8. I have absolute value greater than some. That's this second one here. So it could be that 2x itself is greater than 8, or, and I always remember greater than is the or, greater than is the or it could be that the 2x is less than a -8. When you do the opposite number, you do the opposite sign. That holds throughout. I have 2 little mini equations here to solve. Dividing by 2, I have x is greater than 4, or it could be that x is less than a -4. Is it possible? Is there a number that is greater than 4 or less than 4? Absolutely. So in set notation, this would look like all x such that x is greater than 4 or x is less than a -4. On a number line, with the greater we get wings. So I've got a -4 and I've got a +4. It's not equal to, so I'm going to do an open and to the right and an open and to the left. Right? If you like to do the circles, you can make a circle and pop up and give it wings, but it goes in both directions. In interval notation, we're coming in hot from -infinity, always a parentheses, and we're coming up to, but we do not include a 4, so that's always a parentheses. We need to jump the gap, so that's a union symbol. We're building a bridge over this gap to 4 to a positive infinity. Infinity is always a soft landing. The 4 is an open circle, so it would also be a soft landing. Okay? And then I have the set notation, the number line, and the interval notation. So those are all 3 answers. There's A, there's B, there's C. All 3 parts. All right. Number 5, I tried to do the same thing, but I switched the sign so that you could see what that looks like. When it is less than or equal to, this means that the 2x could indeed be less than or equal to a -8. Because it's less than, this is an and. And it also must be true that that 2x is greater than or equal to a +8. I'm changing the sign on the number. I flip the sign on the sign of the inequality. Still, I get 2 little equations to solve, dividing both sides by 2. I have x is less than or equal to a -4, and it must also be true that x is greater than or equal to 4. Is it possible to squeeze this in such a way that my x values are less than or equal to, or less than less than or equal to a negative 4 and bigger than a positive 4. Is there a number that hits both of those marks? Less than a negative 4, bigger than a positive 4. This just cannot happen. There is no number that works there. This is a no solution. Sometimes with inequalities, it just can't exist. This particular problem goes against the definition. Look at what we have here. Do you see how we have the absolute value and we have that it is less than or equal to a negative 8? We know that absolute value is always positive. The default for an absolute value is a value greater than 0. So I can't have an absolute value that's less than negative 8. And that's why this gives me a no solution. Okay. All right. Let's try number 4. Oh, my little cheat sheet's going out of style, going out of view. Here I have absolute value of 6x plus 1 greater than or equal to a 13. This is greater than or equal to. So that's 6x plus 1 could be greater than or equal to a 13. It's a greater than. So this is an or. That 6x plus 1 is less than or equal to a negative 13. I want to change the sign and change the sign. I have two mini problems to solve here. I'm going to subtract 1 from both sides to get 6x is greater than or equal to 12. Then I'm going to go ahead and divide both sides by 6. X is greater than or equal to 2. It could also be true that 6x plus 1 is less than or equal to a negative 13. 6x is less than or equal to negative 14. Dividing both sides by 6, I get x is less than or equal to a negative 14 over 6, which reduces so that x is less than or equal to a negative 7 over 3. Is it possible for a number or to have solutions that are bigger than or equal to 2 or less than or equal to a negative 7/3? Indeed it is. On a number line, I'm going to take that negative 7/3 and I'm going to take that 2. And this is an OR problem, so it's going to give me wings. X is greater than or equal to a 2. That's a square bracket or a filled in circle, whichever way you prefer, and everything bigger. The other one is less than or equal to a negative 7/3. So on a negative third, that's a filled in circle, and everything less than or to the left. So my interval notation will be from negative infinity, always a parenthesis at the infinities, to a negative 7/3. I want a square bracket here because it can be equal. And then I'm going to have a 2 onto infinity. Infinity is always a parenthesis. The 2 can be equal to. So there, I need to jump that between them, so I'm going to make a bridge between using the union. I've got the number line, I've got the interval notation, and now I just need the set notation. So this is all x such that those x values are less than or equal to a negative 7/3, or those x's are greater than or equal to 2. There's A, my set notation, B, the graph, and C, the interval. I did them out of order. Yankees. All right. Okay. Let's try number 6. Oh, these were out of order. It's okay. It's not a big deal. All right. So in number 6, we've got the absolute value of x plus 1 over 5, which is less than a 1. So I'm going to take that x plus 1 over 5 is less than 1. And because it's less than, it's bounded. So this is an and. That x plus 1 over 5 must also be bigger than, switch the sign, a negative 1. Again, I have two little mini problems to solve. Multiplying both sides by 5, I have x plus 1 is less than 5. Subtracting 1 from both sides, x is less than 4. Doing the other little mini equation, same steps. Multiply both sides by 5. X plus 1 is greater than a negative 5. Minus 1 from both sides, x is greater than a negative 6. Is there a number that is going to be between, because it's an and, right? And bounds it and puts it between. Is there a number that is between 4 and negative 6? Well, sure. If I'm doing set notation first, this is going to be the set of all x, such that those x values have to be bigger than a negative 6, and they have to be less than a 4. They are squeezed in. On a number line, that's going to look like a negative 6 and a 4. I'm going to do an open circle on each. Open circle is parentheses, and I need all of them that were squeezed between. In interval notation, that's just going to be from negative 6 to 4, again using the parentheses. So this one I did in order. There's A, there's B, and there's C. Set notation, interval notation, set notation graph, and interval notation. These two are my favorites. I'm not a huge fan of that set notation. I mean, you might as well just write this rather than set notation. But I do need you to get used to it for some of the other stuff we're doing. Okay. All right, let's try the next, what do I got, 6 here? You see I left a little bit more space for those two because I'll need a little bit more space. Let's give number 7 a try. Number 7 is an inequality, but just like we did for the equations before, we want to make sure that we have this absolute value part isolated. So I'm going to subtract 3 from both sides. That's going to be the opposite of the absolute value of 2x plus 4. And I'm going to have less than or equal to negative 1 minus the 3, which is negative 4. Because I have the negative on the left and on the right, I'm going to multiply both sides by a negative 1. So that's going to leave me with the absolute value of 2x plus 4 and a 4. But because I have multiplied by negative 1, the sign gets flipped. This is now a greater than. So my 2x plus 4 must be greater than or equal to 4. Or, because it's greater than now, it could also be true that that 2x plus 4 is less than or equal to a negative 4. Change the sign, change the sign. All right, two little mini problems. This gives me 2x is greater than or equal to 0. X is greater than or equal to 0. Subtracted 4 from both sides, divided by 2. Similarly, on the other side, I'm going to subtract 4 from both sides. 2x is less than or equal to a negative 8. Dividing both sides by 2, I get x is less than or equal to a negative 4. Is it possible to find a set of x values such that those x's are less than or equal to a negative 4, or those x's are bigger than or equal to 0? In set notation, this would look like the set of all x's such that x is less than or equal to a negative 4, or those x's are bigger than or equal to 0. On a number line, I would use those same points, negative 4 and 0. X's that are less than or equal to a negative 4 are going to be a square bracket at negative 4 because of the equal to and everything to the left. X is greater than or equal to 0 are going to be a square bracket at 0 and everything to the right. Now in interval notation, I'm coming in from negative and infinity, and I am stopping at a negative 4. That is a hard stop because it can be equal. I then jump the gap to get to the 0. Again, it's a hard start or stop at 0. And we're going all the way to infinity, which is always a parentheses. Set notation, line graph, interval notation. 3 different ways to describe that answer. Number 8 is a compound inequality, and we need to split this one up. This one has multiple parts. We know 0 is less than the absolute value of x minus 4. And it must also be true that the absolute value of x minus 4 is less than or equal to 2. So this is actually 2 separate absolute value problems. I'm going to turn this one around just because I am a right to left reader. So this is the same as the absolute value of x minus 4 is greater than 0. So it could be that x minus 4 is greater than 0. Or it could be that x minus 4 is less than 0. Or x minus 4 is less than 0. So x could be bigger than 4, or x could be less than 4. X could be bigger than 4, or x could be less than 4. That's what we're saying here. And if x can be bigger than 4, or x could be less than 4, the only thing we're saying is that x cannot be a 4. Because x can be bigger than 4, but x can be less than 4, but x cannot be 4. So that just looks like an open circle at 4, and we can go to the left and we can go to the right. We just cannot be 4. So it's important to note that what that graph looks like. If we do the other part, this one is less than. So this is going to be an x minus 4 is less than or equal to 2. And it must also be true that x minus 4 is greater than or equal to a negative 2. The less than are the squeeze. They give you the boundaries. So x, adding 4 to both sides, x is less than or equal to 6. And it must also be true that x is greater than or equal to 2. Is it possible to squeeze an x between 6 and 2? So x is less than 6 and x is greater than 2. Yeah, this is going to be an x that is less than or equal to 6 and it's greater than or equal to 2. Now on a number line, this is going to look like from 2 to 6. It's going to be a closed circle, and everything in between. The only problem is, or the complicating factor, is we have a big old and. So both of these have to be true. It has to be true that x cannot be 4. And it also has to be true that x is squeezed between 2 and 6. So when we write this solution in set notation, it's all x such that the 2 is less than or equal to x, which is less than or equal to 6. And it must also be true that x cannot equal 4. Both of these pieces, from this pretty one and from this, have to be true. This would be our set notation. On the graph, what happens is we have our 2 and we have our 6, but we also have to include this rogue 4. So we're going to start at 2 just like we did here. It has to be true for the 2. That's a hard stop or a filled in circle, either way. And it's going to go all the way to the 4, but it cannot be at 4 because 4 is not filled in on both of them. So this is going to be an open circle, or if you prefer, you can do a soft. And then the other way, we do a soft, all the way to the 6, which is a circle, or if you prefer, like me, that filled in square bracket. This would be what the graph would look like. It would be a square on a filled in circle on the square, an open circle on the 4, and a filled in circle on the 6. And we would jump it like this, 6. Right? If you like the circles, it's going to look like that. In interval notation, our interval will start at 2 and it goes up to 4, but it's a soft landing at 4. Then we have to jump over 4 itself, and we can start at something just slightly bigger than 4, and we can go to a 6. And at 6, it's a hard stop. So our set notation will look like this. This is a full statement. It includes both parts. The graph, line graph, could look like either one of these. Both of those are fine. And then the interval notation would look like the bottom row there. Okay. All right. For 9, 10, 11, and 12, this is where you're writing the inequality expression. So we want to express this phrase, for 11 and 12, the graph, as an absolute value, either equation or inequality. I'll give you a hint, all of these are inequalities. All right, so for number 9, we need all real numbers more than 3 units from 0. So what does this look like? On a number line, all real numbers more than 3 units from 0. So there's 0. Here's a positive 3, and here's a negative 3. I'm looking for this and that. All numbers more than 3 units from 0. Since absolute value is a representation of distance, what we're going to do is we're going to take some value x, and we're going to subtract from it 0, because that'll give us a distance. So the absolute value of x minus 0, 5 minus 0, negative 3 minus 0, whatever that is, and it has to be more than 3 units. So it's going to be greater than 3. Notice where the pieces fall here. This is the absolute value of x is greater than 3. Why just x? Because x minus 0 is the same as x, right? So if we're writing this as an absolute value, we are doing the real number minus that middle, whatever point is in the middle. What are we measuring the distance from? In this case, from 0. And it needs to be more than 3, so I'm using greater than. Notice it cannot be equal to 3. If it was at least 3 units, that would be 3 or more. This is just more than 3, so we're just using that one. Let's see what we can put into number 10. All real numbers at most 7 units from 5. So we're looking at real numbers, so it's going to be an absolute value, real number, some number x. The distance is from 5. So this will be distance from 5. So the distance taken from 5 is at most 7 units. At most 7 units means it needs to be smaller than 7. At most, 7 is the biggest it can be. So less than or equal to 7. So our absolute value of x minus 5 is less than or equal to 7. That's what that one is going to look like. Can you do similar from the graph? You sure should. Okay. I don't know how well we can see that. I'm zooming in. This is a little bit hard to see. So here you have a 5. Here you have an 11. Okay. What we want to do is we want to find the middle of 5 and 11. So visually you can probably see that's an 8. What you can do mathematically is you can say 11 plus 5 is 16. And if we do 16 divided by 2 to split that difference, we get 8. So that's going to be our middle point. Any number minus 8. So our centering, we're centering around 8, the distance from some number to 8. Absolute value, distance to 8. Now, how far did they give us? They gave us 3 in either direction. Plus 3 is going to get us to 11. Minus 3 is going to get us to 5. So this distance is clear. It can be bigger than 11 and smaller than 5. So we are outside those. Greater than, that's what gives you wings, right? The greater gives you wings. And can it be equal to? Those are filled in circles. So this becomes x minus 8 is greater than or equal to a 3. I don't know if you can quite see it on the second graph, but this is a negative 4 and this is a 4. Negative 4 and 4. What's the center of negative 4 and 4? 0. Are these boundaries or are they giving us wings? These are bounding us, right? I can't go outside of the 4. So this is the absolute value of x minus 0. And instead of getting greater and giving us wings, we are bounded. And so we are less than. Because these are not filled in, we will not be using an equal to. And we'll be talking about this distance, which is 4. Absolute value of x minus 0 is less than 4. You might have to write it. Absolute value of x is less than 4. You might have to write that. They might not take the x minus 0. I like the x minus 0 because it tells me what it is that you're thinking about. Right? Hopefully this sets you up really well to do your homework. If you have any questions, don't be afraid to hit that Ask My Instructor button and get those questions to me. Thank you so very much.